Session 5.3 Conditional Probability and the Multiplication Rule for Independent Events. Conditional probability. If E and F are events, then the conditional probability is the probability that E occurs given that F occurs. So we are working on the conditional probability. And means here the probability of D. This is what we're looking for, probability of D. And this line here means given that under the situation F occurs. Okay, under the situation F occurs. And we call this as a conditional probability. The order, the E and F, the order doesn't matter, okay? Don't mess up the order. The one who put it in the front, this is talking about the probability. This is what we're looking for. And this line means under the situation F occurs already. So we're gonna base on the F, we're finding the probability of E. For example, a total of 989 randomly selected adults were asked whether they are interested in the international issues. The table compares their response and their age. Suppose a person is randomly selected from the survey. So we have the table here. We have a different age groups, and then this is their response, very interest or moderate interest and not at all interest. And then defining the total for you guys also. Okay, number one, find probability that very interest. What does it mean in this situation? So we're gonna look at it, very interest. We don't care about your age group. I just want to find the probability that they are very interest. So we're gonna use the basic probability formula. So how many of them are very interested? We do have a 226, right? Over the total outcome. Out of the total number of the people, which is gonna be 989. Use the calculator. You're gonna see that's a 0.229. And what does it mean in this situation? So it means that the probability of randomly select a respondent who is very interested in international issues is going to be 0.229. If we only pick one people, and probability will be equal to 0.229. Okay, number two, find probability that very interested. Given that this is a conditional probability, given that or under the situation that their age is between 56 to 89 years. What does it mean in this situation? So this time we're gonna focus on the age group 56 to 89, which is gonna be your green column in here. Okay, we want to find out how many of them is very interested given that they are under in this age group. So look at it, how many of them is going to be very interested? We do have a 106 in here, right? Very interested. And under the situation, they are in this age group. So it's going to be over 370. Use the calculator, it's going to be 0.286. And what does it mean? This means that the probability of randomly select a respondent age 56 and 89 years who is very interested in international issue, that would be 0.286. Question 3. Compare the results you found in problems 1 and 2. What does your comparison mean in this situation? For number 1, we want to find the probability that very interested. So very interested, the total number is going to be 226. over the total possible outcome. That will be 989. And we got 0.229 here. For the problem 2, we want to find the probability that very interested, given that or under the situation, your age is going to be between 56 and 89. So 56 and 89, the total outcome is a 370. And we want to find where we interested under this age, that'll be 106. So you got 0.286 in here. So you compare the result in these two problems. You could see the result we found in the problem 2 is larger than the problem 1 here. This means that if you only pick one people, okay, only pick one people, and their age is between 56 and 89, they are more likely to be very interested in the international issue than the one you pick it from all those surveys. Okay, all those surveys. All those surveys is meaning that that will be including all age. Okay, next example. Finding a conditional probability. A person rolls a 6-sided die once. Find the probability that the outcome is 6, given that the number is even. So you know when you see the given that or under the situation, this is talking about the conditional probability. So first, write it like this way. Probability of 6, this is what we're looking for. Under the situation that the number is even. Okay, the number is even. So first, write down the sample space. What is the even number? We will have a 2 and 4 and 6, right? So think about it. We want to find the probability of 6. How many 6 do we have in here? We only have a 1, right? So that will be 1 over 3 here. That will be 0.333. Okay, number 2. Find the probability that the outcome is an even number, given that the number is at least 4. So this is going to be the conditional probability again. So write down the sample space for at least 4. Okay, sample space is at least 4. At least 4 is talking about x greater than or equal to 4. So we will have a 4 and 5 and 6. And we want to find the probability that this is going to be even. Okay, so even. Which number is going to be even? That will be the 4 and the 6. So the answer will be 2 out of 3, which is going to be 0.667. Okay, independent events and dependent events. Two events E and F are independent if the conditional probability of E given that F, that will be equal to probability of E. And two events E and F are dependent if probability of E given F is not equal to probability of E. Okay, so this part here, they're talking about the independent events and dependent events. And they didn't explain what is the meaning of independent or dependent. They only show you guys the formula, how to prove it, if it is an independent event or dependent event. Okay, let's try to look at some example and I will explain what is the meaning of dependent and independent event. So example, determine whether two events are independent. So we have two events E and events F, and we want to see if they are independent. So this is the experiment. An American adult is randomly chosen. Event E, the person loses weight. Event F, the person lowers his or her daily caloric intake. So if you want to prove if they are dependent or independent, we want to see if this conditional probability will be equal to the probability of E. We want to prove if they are equal to each other. So let me plug it in the event E and F in here. Event E is talking about the loser's weight under the condition that lower his or her daily caloric intake. And we want to prove that if this gonna be equal to the loser's weight in here. So first, think about it. What is the loser's weight in here? For example, I just make up some numbers. Okay, let's say we do have 40 students in here, and we have 10 students lose weight. So if we want to find the probability of loser's weight, we could do 10 over 40. Okay, 10 students lose weight over the total possible outcome. That will be 0.25. Okay, now we want to find the probability that lose weight given that lowers his or her daily caloric intake. So for example, we do have 40 students again. Okay, this is the same example. Total number is going to be 40 students. And we may have 20 students, they lower their calorie intake here. And we do have the same number of the students lose weight. Okay, still 10 students lose weight. So this is a conditional probability. We will have 10 over 20 here. That will be 0.5. So you can see a person randomly select from those who lower their daily calorie intake is more likely to lose weight than a person randomly select from all adults. Okay, so this means like if you restrict your calorie intakes, you should be able to lose more weight, right? Think about it. Does it make sense to you? And that means like they are not equal to each other. Okay, this is not equal to each other. If this is not equal to each other, then that will be the dependence event. Highlight this too. So this is they are not equal to each other. So that will be the dependence events. Okay, number 2, experiment. A person flips a coin and rolls a 6-sided die here. Event E, the coin lands on tails. Event F, the person rolls a 3. So again, we want to see if they are independent. We want to prove this guy. If they are not equal to each other, that will be the dependent event. If they're equal to each other, that will be independent. Okay, so first, we want to find the probability to get the tails. We only flip the coin once, right? So probability to get the tails, that will be 1 over 2. 1 tail over 2 outcome, head or tail. So that will be 0.5 in here. Okay, how about the probability tails given that this is going to be 3? Think about it. I'm going to roll the die once and I'm going to flip the coins once. Will the outcome to get the 3 will be affect the outcome you flip the coin? No, right? This is like 2 different things. When I flip the coin, when I roll the die, they are not related to each other. But this one, we are looking for the conditional probability. Okay, so we know that outcome of the die does not affect the outcome of the coin. And the probability of getting the tails is going to be 0.5, no matter what number is rolled. Okay, since this is 2 different things. So we could say finding the tails is still equal to 0.5 in here. And since they are equal to each other, you know getting the tails is going to be independent of rolling a 3. It means like when I roll the die, it doesn't affect the result that I flip the coins. Okay, multiplication rule for independence event. If E and F are independence event, then P of E and then F will be equal to probability E times probability of F. If you know these 2 events are independent and they're looking for N, And this is means like and then. You want to pick E first and then you want to pick the F. You just need to multiply the two probabilities in here. In words, if two events are independent, then the probability of one event and the other event occurring is equal to the product of their probabilities. So just multiply two together. Okay, let me explain what is the meaning of independent event. Two events are independent. If the occurrence of one does not affect the probability, then the other event occurs. For example, tossing a coin, head or tails, is not affected by the previous toss. Okay, this means if I want to flip the coins, I want to get the head first. After that, I'm gonna flip the coin again, and I want to get the head. So that means like head and then head. So think about it. What is probability to get the head for the first time? You're gonna get 1/2, right? We only have a one head over the two outcomes. And then I'm gonna flip the coins again. Okay, I'm gonna flip the coins one more time. What is probability to get the head again? It doesn't change, right? It's still 1/2 here. Okay, we call getting head and then head, this is an independence event because the probability for the second event, it doesn't affect by the previous one. It doesn't matter first one you get the head or tail, I still have the same probability to getting the head. So we call this is gonna be independence event. Okay, try this example. A person flip a coins and roll a 6-sided die. What is probability that the person rolls a 4 and the coin lands on the heads? So we just prove it. When you flip the coin and roll a 6-sided die, this is an independence event, right? Because the outcome doesn't affect for the next events in here. Right now, I want to find the probability that we got the 4 first. And then we want to get the coin lands on the head. So we just write it down. We're gonna let the event F be the rolling a 4. And we're gonna let the H when we get the head in here. So we try to prove it whether the given events F and the H are independent. And we already saw it from the previous example. Flipping a coin and rolling a die, this is a two different events and this is an independence. So we'll be using the multiplication rule. Getting a 4 and then we're gonna get the head. So that'll be probability of 4 times probability of head. So think about it. What is the probability to rolling a 4 when you roll the 6-sided die once? You will get 1/6, right? Only have a 1/4 out of total outcome, 6 outcome. What is the probability to get the head? That will be 1/2, right? So multiply it, you're gonna get 0.083. Okay, number 2, 3 coins are flipped. What is the probability that all the outcomes are tails? So this is talking about the first time when I flip the coin, I want to get the tail. And then I'm gonna flip the coin again, I want to get the tail. And then I want to flip the coin and I want to get the tail. So the 3 outcomes of tails are independence event, right? The first time when I get head or tail, it doesn't affect the next time when I flip the coin again. So this is gonna be independence event. So we are looking for probability of tail and tail and tail. So we just multiply all together. So think about it. First time, when you flip the coin, you want to get the tail, it's going to be 1/2. Second time, when you flip the coin, you want to get the tail again, it's also 1/2. And then last one also. You're going to get 1/8 in here. Okay, complement. Find the probability that an event occurs at least once. Then we can find the probability of the complement and subtracting from 1. Remember we talked about the complement in the previous sessions. What is the meaning of complement? If there are 60% win, then that will be 40% it will not win, right? Win and will not win, this is called the complement. When you add it up, should be equal to 100%. And then we have the complement formula, and we could revise it to 1 minus probability of complement of A here. So if you guys looking for the probability, say at least once, okay, finding the probability the event occurs at least once, you're gonna think about like this formula, okay, the complement formula. And at least once here means one or more, okay, one or more. And the complement of getting at least one particular event is that you get no occurrence of the event. So for example, if I let probability of A, my A means get at least one blue marble. Okay, get at least one blue marble. So what is the complement for the A in here? That will be not to get any blue marble. Okay, so this is gonna be complement. At least once the complement of it will be not to get anything, not to get any blue marble. Okay, let's try to use the example to explain like this formula. A fair coin is tossed 5 times. What is probability that it comes up heads at least once? I want you guys highlight the at least once here. One more time, at least once means I want to get one or more. Okay, so first, write it down, probability of A equal to comes up heads at least once. What is the complement of A in here? The complement of A will be not to get any heads, right? Not to get any heads. But think about it. I'm flipping a coin. I only have either head or tail. If I don't want to get any head, that means I'm gonna come up tails all the 5 times. Okay, I want to get all the tails. So now we'll be using the complement formula. So this is what we're looking for. Probability that comes up heads at least once. And we'll be using 1 minus probability of the complement of A. Okay. So think about it. I'm gonna flip the coin 5 times. Okay. I want to flip the coin 5 times. What is the first time to get the tail? Okay. The first time when you flip the coin, what is the probability to get the tail? There will be 1/2, right? Only one tail over head or tail, 2 outcomes. And then after I get the tail, I'm gonna do second time, I want to get the tail again. Okay, because this is a probability of come up tails all 5 times. Okay, so first time I get the tail, second time I want to get the tail again. It's gonna be 1/2 again, right? Because this is an independent event. It doesn't matter the first time what I get, it doesn't affect the second time I want to get the tail. Okay, how about the third time I want to get the tail? What is the probability? Same thing, right? 1/2. The fourth one, 1/2. The fifth one is gonna be 1/2. So now I'm gonna multiply all together. So that'll be 1 minus 1/2 to the power of 5th. Okay, use your calculator. Make sure you know how to use your calculator to get this guy. You should get 0.9688. Okay, next example. For the spring semester 2014, 57% of students are female. Okay, so 57% of students in this college were female. If 4 students were randomly selected with replacement means after you pick one student, you put it back and then you want to pick the second person. What is the probability that at least once of the students could have been female? Okay, you're gonna see at least one, okay, at least one female in here. And then we want to pick 4 students. One more time, when you see at least once, you want to let the probability first. Probability of A, female at least once. Think about it. What is the complement of A? At least once, the complement of it will be no female at all, right? None of them are female. So if none of them are female, that means we want to get all male. Okay, we want to pick 4 students, it's going to be all male. So use the probability formula. Think about it, what you're going to put from here. You don't put 1/2 in here, okay? Because they assume that 57% of students are female. Okay, so write it down in a probability. P of F, probability to get the female is going to be 0.57. Think about it. What is probability to get the male? We assume that either you're going to get male or female, right? So male and females, that's the complement. If there's a 57% of female, so you know that will be 43% is going to be the male. So the first one, what is probability to get the male? Okay, it's going to be 0.43. Second one, what is probability to get the male again? That will be the same number. Okay, one more time. This is probability of the complement of A. Means I want to find probability of all males when for these 4 students. 1, 2, 3, 4. Use the calculator, you're gonna get 0.966. So probability that at least 1 out of the 4 students would have been female is approximately 0.966. That's it for the session 5.3.